This is all about computers, purpose, and design. So nowadays, computer devices are everywhere. They're in our dishwashers, they're in our phones, they are in our cars. So what are different types of computers that we use in the workplace, and what are their purpose and design? First of all, you may work on a desktop computer, and a desktop computer will have a monitor, a keyboard, a mouse, and a tower. You may also work on a laptop, which can also be called a notebook, which will open and close, kind of like a clamshell. Uh, you may also work on a tablet. I love to add this really old picture to show what really old tablets look like. Here's a more modern looking one. And tablets will have a touch screen and interface rather than a keyboard. And now we're also seeing a mixture of tablets and laptops where you may have a keyboard attached to a tablet, like a Surface or something like that. You may also work on a virtual desktop or a VDI. Sometimes these are also called zero clients or thin or thick clients. And this is where your computer does not actually have a hard drive and everything is stored in a larger computer that is sending the information to smaller devices. These are often used in large businesses where they do not want to have individual computer storage and towers in an office space. And this allows, for example, the techs of a business to work on the computers remotely very easily and make changes to all of the computers quickly and easily. This also allows people to have access to specific software without having it installed on each individual device. You may also come across business and government computers. You may see a mainframe computer, which is very large, and these are used for processing tasks like statistical data, payroll, bank deposits, and these can support thousands of users, so computer users like you and me, and multiple programs. You may hear about supercomputers. Now, supercomputers are the most powerful computers, but they usually perform one specific task, like crunching scientific numbers, so they'll be super, super fast, but limited in scope. You will also hear the term server. Now, a server can be any size. It could be the size of a mainframe or it could just be a desktop. And a server is used to connect other computers. So a server serves these computers. It sends files from one computer to another. It allows communications, applications, even access to games. These computers are often called a host computer, whereas the computer that it serves are called clients, much like in our zero client example previously. Some are as powerful as mainframes, but you could have a server in your house that is just a desktop computer that connects several other computers in your home or in a small business. There are lots of other computer devices out there, as I mentioned, anything from gaming and phones to night vision goggles. We can see this really cool robot on the bottom that was designed to handle people more gently than even people can handle people. And we're even seeing a robotic and human interface. So these are also computer devices. How does all this work? Well, this is going to be a tricky part of this conversation that we'll have in this class, and I'm not expecting you to have a large, deep scientific understanding for this class of how computers work, but a surface level understanding. So I'm going to talk a little bit about binary and how binary works, because it will affect how you understand the amount of storage and RAM, etc. in your computer. So, binary is counting with only ones and zeros. Now you may recall that Turing, in our computer history presentation, thought about having a computer that ran on ones and zeros. So there's always been binary counting out there, and he thought of using it to create a computer. So counting in binary is only using 1 and 0. So usually we use a 10 number system, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But binary is bi, meaning only 2, like bicycle or bilingual, and binary only uses 1 and 0. So if you wanted to write 17 in binary numbers, you would see that across the top here, I have, rather than 10 spaces where you would create the standard numbers that we work with, where you'd have a 1 space, a 10 space, a 100 space, a 1,000 space, etc. Instead, you'll have a 1s, a 2s, a 4s, an 8, a 16, and 32. So when you write in binary, if you were writing 17, you would have a 1 under 16 and a 1 under the 1 space, and you'd have 0 in all the other spaces. Now, you wouldn't have this grid if you were writing in binary. You would just have these numbers, and this stream of numbers would represent the number 17. How would you write 41? You could pause the video and see if you can think it out. You would have a 1 in the 32 space, you'd have a 1 in the 8 space, and you'd have a 1 in the 1 space and zeros in the other slots. So how is binary used by your computer? Binary works as the language that the computer understands. And the computer takes each item that you work with that makes sense to you and converts it to a letter or a symbol or maybe even a little square or pixel of color to create an image. So for example, that would stand for capital A, for capital B, and capital C. When we talk about data and the amount of storage or memory or working memory that you have in your computer, you're going to be talking about bits and bytes. A bit is short for binary digit, and that's the smallest unit of information storage that you can have in your computer. So your computer thinks in ones and zeros, and every 1 and 0 is a bit. A byte is 8 bits and represents something like a singular letter or number or a stream of bits that may create a visual image for a program that displays images. So you'll have bits and you'll have bytes. You'll need 8 bits or more to create a byte. When you're talking about how much storage you have in your computer, you may be looking at megabytes, gigabytes, and terabytes. So megabytes are about 1 million bytes. So that's all those bytes put together. And often nowadays we're more likely talking about gigabytes, which are 1 billion bytes, or terabytes, which are a trillion bytes of storage. So this is all those ones and zeros stacked up together so that your computer can understand and you can interface with your computer. So when you're looking at how much storage your computer has, this is how it's measured. So you may have more storage on your hard drive. You may have more RAM, which is your random access memory, so that your computer could run complex videos or work on lots of different programs at the same time. Or maybe you're looking at a computer and all you're going to do on that computer is write documents, so you don't really need tons of RAM or you don't really need tons of hard drive storage. So again, being able to understand these different levels of storage and that is connected to your bits and bytes is important. Maybe you're thinking, what? I don't really understand what binary is. Well, part of this week's lab is to do an extra credit assignment called the binary assignment. So if you are still interested and want to learn a little bit more about binary, you can go to the next part of this section here, and you can do another assignment and watch a short video about how binary works.